Hello everyone, this is Chen Liu's presentation. Today, I will introduce you the patch match algorithm and its application. Patch match is a very good method which has been used in Adobe Photoshop CS5. Patch match is a search algorithm which aims to find the best patch from the source image. Then we can use this patch to do many other applications. For example, image inpainting or image reshuffle and image retargeting. The method of patch match is mainly developed from several reference papers you can see in this slide. And one of the most famous is a randomized correspondence algorithm for structural image editing. In this presentation, most of the methods and the pictures are from this paper. Many recent image editing approaches take high-level image constraints as input. For example, a change of aspect ratio or inputting a marked region. But most of them are too slow in memory intensive for interactive use. How to solve this problem? Now, let's leave this problem for a while. At present, we have all used Photoshop to do some image editing. So let's first look at some example. Reshuffle is to rearrange an image, such as pasting the tower in the upper right corner of the image to the left and making it look natural. In the left finger, we can see that the edge of the tower has a very obvious boundary. In order to eliminate the boundary, we need to fuse the edges and other operations. The general method is to solve the Poisson equation. The reshuffle in match patch doesn't solve this equation, but finds the most matching region between the edge part and the other parts of the picture, and uses this region to fuse the boundary to achieve the natural effect. The result is shown in the right finger. Next slide is about a video of this operation in Photoshop using high-level constraints like a drag and drop recomposition of an image position. Every operation can be controlled under user specified constraints. This is the video of image inpainting and retargeting. In this video, this example, the roof line was completed use patches from another part of this roof. A hole is marked, and we use line constraints you see in red, in green, in blue to improve the continuous of the roof line. Finally, the hole is filled in. So for now, let's turn to the problem. Most of recent image editing approaches are too slow in memory intensive for interactive use. So how to solve it? The author proposes an interactive image editing tool based on randomization algorithm, which is used to quickly find the corresponding small area between two images. The main idea of the algorithm is that we can find some good patch matching by random sampling, and according to the natural consistency of the image, we can quickly propagate this patching to the surrounding area. This figure shows that what is matched patch. We can see that the patch is just some small squared area of pixels. such as 3 times 3, 5 times 5, or 7 times 7 times 5, 7 pixels. And we want to get best matched patch in the source image to the patch in the target image. Patch has more meaning than just a pixel and is small enough that computations don't take too much time, like comparing two patches. These characteristics are of great importance as pixel do not include enough information, and we need to calculate lots of comparisons between patches. So patch is a small squared area of pixels, and then this paper introduced a good random search algorithm to get a approximate best result. Approximate means that it can be very close to the best result, but its advantage is the speed. By random search, it can be much faster than others. And even the result is not the best, it is enough for us to do the next step. The previous approach would be to search for every patch in the target image, the best matching patch in the source image. However, this has a high time consumption, so the paper uses use approximate nearest neighbor. We call it ANN. ANN is based on random values, and we don't need a perfect match to gain good results. And then we get the next problem. How to find the best patch between two images? We will use the offset match. The answer is offset maps. To find the best match, we need a recorder. The connection between those two images is the offset match. It has the same dimensions with the target image. The offset map stores relatively which patch in the source image match best to the patch in the target image. So that means what we need to get is that the most matched region of target image in the source image, and this is recorded in offset map. This is the output result of match patch is an offset map. This is the algorithm. It is divided into 3 parts. First one is initialization. Second one is propagation. The third one is search. I will introduce them one by one in the next slide. Patch match algorithm is a method to find the approximate nearest neighbor. The key idea of patch match is to use the consistency of the image. The nearest neighbor of the patch, which is near patch A, is most likely to appear near the nearest neighbor of patch A. Using the consistency of the image, the search scope is greatly reduced, and the most points can converge as soon as possible by iteration. For each patch in the target image, it is necessary to find the most matching patch in the source image. The final output of ANN is an outside map recording the corresponding position. Since the sizes of two images are the same, it is only necessary to record the offset of the patch A from the corresponding patch B. The idea of patch match nearest neighbor algorithm is that if the patch A matching patch B of target is found in the source, then the region around the patch B is likely to match the region around the patch A. That is the local correlation of the image. So the global search is not needed. For example, in this finger, if the corresponding block patch D or patch B is found in the target image, then the corresponding block of patch A is likely to be patch B. So let's come to the detailed steps. Initialization. Each pixel is given a random patch offset as initialization. Each pixel in finger A is given an offset randomly, and a corresponding pixel is found in finger B. In the finger, 3 pixels of the whole picture are selected as the display. In addition, the author adds 2 tricks on the basis of random initialization. The first one is initialize the offset map value of the boundary value to 0. The second one is the offset of the covered area is pointed to its original place. And then constraints are used to prevent ANN from modifying it later. Propagation next step is propagation. Each pixel checks if the offsets from neighboring patches give a better matching patch. If so, adopt a neighbor's patch offset. It may not be easy to understand here, but I can give you an example. Look at the finger first. Compare the similarity between the blue block in A and the offset block in B, and record it as similar 1. And record it as similar similarity 1 blue, and then compare the similarity between the blue block in A and the green and the red blocks in B. Here, similarity means the lowest distance, and then record it as similarity 2 green, similarity 3 red. Compare similarity 1, similarity 2, similarity 3. Which block in B is most similar to the blue block in A? The offset of the corresponding block in A is assigned to the blue block. If similarity 1 is the largest, the offset of the blue block in A remains the same, or corresponding to the blue block in B. If similarity 2 is the last, the offset of the green block in A is assigned to the blue block. In this way, the blue first corresponds to the green block in B. Obviously, this process cannot find the most matching block, so there is a third step. Search step. Each pixel searches for better patch offsets within a concentric radius around the current offset. The search radius starts with the size of the image and is halved each time until it is 1. The radius of the search starts with the size of the image and then decreases by 1 over 2 of the convergence rate until radius equal to 1. The random search, this step, search for good patches from offsets around a certain region around the current pixel. If the expression radius is below 1 pixel, the random search stops. Well, now that we have three steps, we can start the iteration. That is, repeat step 2 and step 3 until each pixel finds the most appropriate and accurate offset. That is, each pixel in A finds the most matching pixel in B. Let's go back to the first picture we showed. The red patch in tangent image has its own corresponding red area in the source, and its left black patch has black corresponding black area. Now we compare the black and the red areas in source with the red patch in the tangent. If the black area is low, then we change the red patch offset maps values to the green area in the source. After that, the area in the source will random deviate to different locations. If one location is more suitable, then the patch will change its offset maps. Patch match is just a search method. If we want to use it for real applications, for example, image compilation, we should use other method. And the algorithm is very simple. After we found the patch, we just replaced it. But how do we replace is also a question. And now we have three tools. They are Adobe, image compilation, and image reshuffle. Here we have three methods to complete the method, to complete the image. You can see in the table, Adobe, image compilation, and image reshuffle. Some are software, some are code. Now we compare every method using one single image. This is the original picture, and we want to complete the left dark hole. If we use Adobe Photoshop, we need some interaction. Its advantage is that it is very fast, but we may see the left and up border line. Of course, sometimes we need to keep the line straight, but sometimes we don't want it. If we use the image compilation software, it will cost a lot of time, and the effect is not very well. What's more, we need to mark the hole with a special color. The interaction is very much. When we use the method of image reshuffle, we just to make a rectangular like this one, and drag it to the hole. Then the result comes, but it costs some time, and its outer border may be bent. So we come to the conclusion. Different methods have different advantages, and we can select and combine them to get best effect. Thank you for listening, and do you have any questions?